Along Canada's east coast and up through its northern ports, one company stands head and shoulders above its competitors in the business of marine construction, especially when it comes to the construction of slip-form concrete caisson wharves. McNally Construction was founded in 1949 and has perfected this innovative method of wharf construction.
This is an incredibly efficient way to construct a dock. It doesn't require large equipment. We don't have to have massive cranes. We're not driving piles into the ground, but instead we're able to cast concrete, very durable, very long-lasting concrete right on the deck of a barge, immediately, within days, float it into the harbor and then build the structure right off on top of that without any additional equipment. It's just, again, it's very fast, very efficient, very cost effective.
McNally is often chosen to work on marine projects because of our record of performance, our record of safety, our record of quality workmanship.
We're the largest marine contractor. We've got the most highly skilled and experienced field personnel and very specialized marine equipment, and it's a combination of those things that really set McNally ahead of the competition.
We are one of the leaders in marine construction here in Canada because we have a large fleet of floating vessels, and the largest fleet actually in Eastern Canada. The first part of the project is typically dredging of the soft sediments to produce a better foundation for the concrete crib. So spud barges would go in, drop their spuds to the seabed, hold the dredge in location for the dredging to actually take place. Then we also use our spud barges for location when we're placing our mattress, our foundation stone for the mattress below the concrete caissons. We have a fleet of dump scows which we use to, number one, haul away the dredge spoils, either for ocean dump or onshore disposal. Those same dump scows are utilized for placing the mattress material from shore out to where the foundation for the crib will be created. We have a large platform, a large surface on the Beaver Neptune for us to pour the slab for the base of the concrete caissons.
The deck of the Neptune is specially prepared with bond breaker to ensure that the crib can easily slip into the water when the Neptune undergoes partial submersion during the launch process. Once the slab is complete, specially prepared slip forms are carefully but quickly positioned on the slab. During this phase of construction, more than 100 hydraulic jacks strategically placed on the forms are clamped in place and connected to a central hydraulic jacking system. Concrete is then poured around the slip forms, bonding to the slab below. As the concrete fills the slip forms, it is regularly tested for quality and initial set. Once the concrete at the bottom of the forms has hardened or set to the correct depth, the jackman then triggers the hydraulic jack system, and the entire set of interlocking slip forms is raised 1 inch above its original resting place.
Yeah, like I said, the jacking system is pretty simple. They're 3-ton jacks. There's 126 on this crib, and every time you turn the button to snap the pump on, they jack all at once, and you jack an inch at a time.
You can't go to school. It's basic. Just learning. Like as far as the concrete, I've got a prod rod, a steel prod rod. That makes my living, son. Just the feel of the concrete, how fast you can jack, how the concrete's setting up. You can pretty well tell how fast it's going to set up.
Wayne and Edgar LeBlanc are second generation jackmen. Their fathers worked for McNally for many years on the cribs, building cribs.
The pouring of concrete continues uninterrupted. This process is repeated until the walls of the crib are approximately 4 meters high. This is a critical milestone in the construction of the crib because it is now ready to be launched. Forward compartments of the Neptune are flooded, causing the bow of the barge to submerge, and with a little assistance from the tugboats, the crib slips free of the Neptune's deck and is launched into the water.
Beaver Neptune has a great capacity from a weight perspective as well to support that concrete slab, that concrete caisson, until it will actually float on its own. The slab in the first 4 meters of the caisson weighs approximately 600 tons.
The tugs then move the floating crib to a position where it can be secured and prepared for the second stage of the slip form process. Within hours, the concrete is flowing into the forms once again. Over the next 4 days and nights, a steady flow of concrete is delivered and poured into the forms. Slowly but surely, the crib takes shape below the waterline. Rain or shine, the process continues. Slip forming in this way produces extremely solid concrete walls free of any cold joints, cracks, or flaws. Inch by inch, the slip forms are carefully jacked up above the hardened concrete walls, revealing a perfectly formed concrete caisson section of wharf. Once the walls of the crib have reached the specific height, 16 meters in this case, the jacking system is disassembled and removed along with the slip forms. In the meantime, another base slab has been prepared on board the deck of the Neptune. The slip forms are cleaned, oiled, and put into service once again to begin the construction of yet another crib. Finished cribs are floated to their final destination and then positioned using a system of cable pullers connected to spud barges. Tugboats are also employed to assist with the final adjustments. Positioning a crib before it's allowed to rest on the mattress below is a critical phase in the construction process. Spud barges and tugboats are used to inch each crib into its proper place. A surveyor on site takes readings at regular intervals and provides accurate GPS information to the construction manager so that small adjustments can be made to the crib's position.
We're working with 75 mil tolerances in any direction, but when the crib goes down, we try and put it within about an inch, 25 millimeters when we're down.
Once everyone is confident the crib is floating exactly over its intended coordinates, the crib is slowly sunk into place on a falling tide to ensure it comes to rest exactly where it belongs. Draft marks on the crib aid in measuring the rate at which the crib sinks. The sinking of the crib is managed through a series of connecting conduits in the crib walls. Ballast valves are used to control the flow of water into the empty cavities of the crib. As the tide goes out, the crib slowly sinks into position to meet the mattress below. Once a crib is completely settled on the bottom, it is filled with crushed rock, displacing the seawater with permanent ballast stone. With the new crib safely settled into position, the McNally crew turns their attention to the next crib already taking shape aboard the Neptune.
Our goal is to have an incident and injury-free workplace. And a key part of that goal is having workers themselves watch over each other.
Projects of these scale don't happen in the same location, close to home. So we have to travel together. We spend more time with each other than we do with our own families. And we really become a family.
You have to build a team every time you go to a different city. The labor is the backbone of this thing. And I tell them that. Without you, we can't do this.
Andre's worked for the company for 35 years. His mandate at this point in his life is to educate the younger generation, our younger supervisors, to carry on to the same level of precision that he carries in his own work.
And one of the great things with McNally Construction is the passing of the torch, where we have senior supervisors who spend time to make sure that that knowledge is passed down to the future supervisors. Concrete caisson construction is very economical versus steel sheet pile construction versus king pile construction. It offers speed, schedule saving. We can produce 120 feet of finished wharf in a week, which in these days of tight construction schedules means savings of dollars. We've got longevity that exceeds 75 years, and with little to no maintenance over that time period. In northern climates, the biggest factor you have to deal with is weather and a very shortened construction season.
We've slip-formed concrete caissons, constructed them in the south, and transported them on heavy lift ships to construction sites in the Arctic. We can produce the cribs in one location and transport them virtually anywhere in the world. With a concrete caisson, what you really have is a portable wharf. 50 years from now, these cribs can be deballasted and could be refloated and moved to a new position. You're not doing that with pipe pile dock?
Well, certainly for port authorities, it's a very efficient way to build new infrastructure for them, but also for remote sites where you have very limited access to those sites, where you can't bring in the large equipment, sites where you have limited water depth. This method works well without having to worry about having deep draft vessels come in.
The process all comes together when you have the right mix of equipment and the right mix of people and expertise. And those are the recipe for making a successful project.